Hi, welcome back to the breadboard. In previous videos, if you've been paying attention, you'll see that I have a few themes going on. One is my power supply project, another one is my CNC, but the one that's relevant today is industrial control. I've done a few videos where I've looked at PLCs, some various aspects of chips that help with industrial control, and how to do a few things with Arduinos, Raspberry Pis, etc. What I haven't done up to now is looked at industrial PCs. Obviously, a normal PC that you'd buy for your house or something like that is good to work between, say, 5 or 10 degrees up to maybe 35 or 40 degrees C. But what do you do when you have an environment where you need PC computing power, say an i7, running either a Linux or a Windows operating system, but it's got to work in an industrial environment. And I'm talking anywhere between, say, -20 to -40 degrees centigrade up to, say, +70, +80 degrees as well. This could be, on an aircraft, it could be on a boat, it could be in a train, it could be simply in a factory that doesn't have heating, or maybe it's some industrial environment where there are furnaces or other sources of heat where the environment will get really, really hot. So in an industrial PC, you also couldn't afford to have fans sucking in dirty air and things like that, because it would very rapidly coat the inside of the PC with crap. It would clog up the fans, and eventually things would start overheating and failing. The company's in Taiwan called Perfectron has sent me an industrial PC to review. So that's what this video today is going to be about. The one that I have is the PER335A. It's the configuration I have has got 4 gigs of RAM. It's an i7 quad-core processor mobile chip, and it's got 5 serial ports, of which they can support either RS-232, RS-485. It also has 2 Ethernet ports and 4 display options on this board, including VGA, DVI, HDMI, and Lvds. What makes this PC special is basically it can handle all of the environmental conditions I just mentioned previously. So let's go and have a look at the actual hardware and take the lid off and have a look what constitutes the building of an industrial PC. So what is notable about this is got 2 LAN ports, 4 USB3 ports, one of the COM ports, VGA, DVI output, and HDMI output. But the other thing to note here, which is typical of an industrial PC versus a home or office kind of server or PC, is that this one is actually powered from anything between 9 to 26 volts DC. So in an industrial environment, it is very common to have devices running either on 12 volts or more typically a 24 volt supply system. And many of the PLCs that you've seen me review in the past have been powered by 24 volts DC as well. There's also mounting brackets so that you can screw it to a wall. There's also 2 rubber bungs on the front here for connecting antennas if you have this with a Wi-Fi module inside. Here's the back of the unit now. You can see here we have a Compactflash fast port so that you could actually plug in some memory as a rugged memory kind of thing for this. You've got your power switch and your power light and hard disk activity. I guess this kind of makes this the front if you're going to be having the power light and power switch and everything, but either way, this is the other end of it. And also on this panel we have 4 COM ports. Now, as I said, some of these can be configured as RS-485, RS-422, and RS-232. The other thing you'll notice is that there are no fans. There are no external holes on this. Let me just zoom out a little bit. As you can see here, if I move this box out of the way, on this front panel, this is the bottom of the unit we're looking at here, and there's a little hatch here so that you can access to any hard drives, whether they be solid state or 2.5, any kind of 2.5-inch SATA hard drive will work. You've got 3 mounting holes so that you can actually screw panel mount brackets on here. So it just takes a few screws, and we'll do that. And then you can just hook it onto a wall or something like that quite easily. Or you can just sit it. It's got rubber feet on one end of the panel so that you can actually sit it up without it, you know, scraping any of the connectors or anything like that quite easily. It's got handles on the other end, of course, so that you can lift it up, move it if you need to. And basically, as I said, no fans. But what you do see on each end are massive full depth heat sinks, all right, on both sides of this. So let's have a look inside and see what this is all, how this is all hooked up. Let me just move these mounting brackets out of the way. So the top panel can come off with just 6 screws. There's 2 at the front, 4 on the top, and then it just slides off just like that. Let me just put that aside. Now let me just zoom in here. So now we have the lid off. Let's have a little tour of what's inside here. Let's start with the bottom right and work our way up to the top left. So first of all, we've got the audio jacks here. We've got the LAN and 2 USB 3 ports, another LAN and 2 more USB 3 ports, the common HDMI connection. We've got the VGA and DVI connection, and underneath the common HDMI. And then we have the DC input over on this far end, which is via this cable up to the front panel with that connector. Going back a little bit and coming across again, we have a mini PCI Express connector here so that you can actually put in a card. There are 2 standoffs here, one here and one over here for screwing it down. So depending on the size of the mini PCI Express card you put in there, it will accommodate either size. We have the QM77 mobile Ivy Bridge processor here to give us all of our I/O and everything else. We have the Ivy Bridge processor itself, which underneath the heatsink here, I'm not going to remove it, is an i7 quad core that's been installed here. We have 2 SATA 3 ports here, and we have 2 SATA 2 ports on board. We have obviously power connections to go out to the hard drives as well on the board. One of the things that is in here, obviously there's a lot of cables. This is the front panel cable right here that I'm wiggling. Underneath here are 2 connections that are for digital I/O. There's actually 16 bits of digital I/O available on the motherboard. These haven't been brought out to a panel or anything, and I haven't yet found out if there are any options to use them, but it's something to bear in mind if you're building a small industrial control solution and you need a PC with a lot of power and a little bit of I/O built in, maybe to drive some relays via a driver board or something like that. Additional USB 2 ports as well are also available over here. There's 4 of them. You have a standard PCI socket and a PCI Express ×1 socket over here. 5 COM ports sitting at the back, which are all plugged in and coming to the back panel. There's only 4 plugged in, 1's not plugged in. So there's 4 COM ports coming up to the back panel here, and there's an additional one on the motherboard that's not plugged in. Anyway, this is the Lvds port. There's no sockets on here to connect an Lvds, so I'm not going to be able to test that even if I had one. Yeah, the SODIMMs that are in here, this one's a 4 gig as I said, and it has room for 2 SODIMMs, and you can go up to 16 gigabytes in total, so you could replace these with a couple of 8s. Now remember, this is an industrial PC, and this particular one has an extended temperature range, so it will go from minus 40 degrees centigrade up to plus 85 degrees centigrade. So if you put in your own memory and you want to operate it to those ranges, then you need to make sure that you put in memory chips that are capable of working down to those kinds of temperatures. Obviously, when this thing is actually physically operating, it's going to warm up inside because of the CPU and everything else. But if you're starting it from cold, then it's going to be feeling those extremes. Now, obviously, if you're at the high end of the temperature range, then you could be powering this up with an ambient temperature of 80 degrees centigrade, and you still want this to be able to work. So if you do add your own parts, make sure you put in parts that are capable of handling the temperature range. The whole thing works from a 9 volts to 24 volts DC input range, and what you have down here is this is all power regulation circuitry around the CPU. All of these big bricks are inductors, and you've got some switching logic and everything else, which allows you to feed this in with your 24 volts, and then it's going to break it down to the various supply rails that the CPU is going to need to operate. Now, this motherboard is actually designed and built by Perfectron. If you look up the INS8335A using Google or something, all the datasheets will take you back to Perfectron datasheets. This is designed specifically for industrial control applications, and as you can see from the specifications I'm giving you, it has quite a range, an operational range of temperatures and everything else. Now, it's also immune to a significant vibration and shock and everything else. As I say, this is designed to go into aircraft, trains, boats, military vehicles, or at least, you know, all-terrain vehicles and things like that, where there could be a lot of shock and vibration that these boards would get subjected to. So they need to be made to be very, very rugged. Relative humidity is going to operate between 10 and 90% relative to humidity, non-condensing. COM port 5 and 6 can operate either as RS-232, RS-422, or RS-485. COM 4 supports RS-232 on the pin header. COMs 2 and 3 are RS-232 only, but you can select whether it works with 5 volts or 12 volt. Now, all of the video on this uses an integrated GFX processor in the Ivy Bridge CPUs. It's got VGA up to 2048 by 1536. It can do LVDS 24-bit up to 1920 by 1200, and the onboard DVI and HDMI can do up to 1920 by 1200, so beyond standard HDMI resolutions. And all 4 of the displays can work independently if so desired. Now, like I said, this motherboard does not have the LVDS connector on it, so I couldn't connect one of those up even if I wanted to, like I said. Audio is a standard Realtek ALC892 high definition audio, and it uses Intel Ethernet adapters. It supports Wacom LAN, and it can boot from a PXE host, so boot from LAN support is fully built into this. This particular PC can come either in an Intel Celeron, an Intel i3, an i5, an i7 in an extended temperature range using the 22 nanometer Ivy Bridge processors, which will give you -40 to +85 degrees C, and another option, which is the INS8335A-ET, which gives you -20 to +70, which is more of a standard industrial temperature range. So with the i7 quad-core processor in here, it's designated to consume about 45 watts during operation, and the processors run nominally at about 2.3 gigahertz. Now, based on some of the charts that you should be seeing on the screen right now, you'll see that as it gets colder and colder, they're able to actually crank the speed up to in excess of 3 gigahertz, obviously because of the extra cooling and everything else. As the environmental temperature approaches 85 degrees centigrade, though, you'll see that the temperature or the processing speed needs to get throttled down to nearer about 1 gigahertz, but it's still working fine, and it's using some of the standard throttling that's built into the CPU and the design of the motherboard. So I think from an actual electronic perspective, the last two things to show, well, the last one thing to show inside here is this adapter up here. This is actually a Compactflash Sata adapter. So it's not your regular compact flash cards that you would find for your camera, but one that actually has a SATA interface. And you can see here you've got the SATA data cables and the SATA power cables. They're coming up and they're connecting directly to here. So the card would have to have a SATA style connector on the end of it, even though it is compact flash. So part of the specifications for this industrial class computing system is that it has a lot of vibration and shock resistance capabilities built into it as well. And just to quote you a couple of the specifications that are on the data sheet for this, part of the testing is they subject the whole computer, this whole unit that we're looking at, to 100 Gs of acceleration in a half sine wave for 6 milliseconds. So that would be the equivalent of probably dropping it on the floor, or hard bumps in a vehicle and things like that when it's mounted somewhere. And the other thing is vibration tests, again something that would be endured if it was mounted in a vehicle or in a heavy industrial kind of environment where they subject the board and, well, the whole computer to 5 Hertz to about 500 Hertz with a 3G RMS acceleration in all 3 axes, and they do that for about 30 minutes as part of the certification testing. So that's quite extensive mechanical structure integrity that they're ensuring here, which is why obviously, you know, when you look at, say, the SODIMM here, they've actually put a cable clamp around it to make sure that even when it's subject to vibration, these clips are not going to be coming apart. Up here you can see that the SATA cables have a little bit of adhesive that holds them into place so that they don't come loose. You know, everything is either screwed down, bolted down, or glued down to make sure that, you know, there's nothing going to be breaking apart and reducing the reliability of this PC. So the last thing that I want to point out inside of this is the heat sinking, the heat distribution capability. What we have, even though these are silver in color, are solid copper heat pipes coming out from aluminum blocks that are directly mounted to the CPU and distributing the heat evenly to these dual aluminum heat sinks that are mounted on both sides. In fact, they make up the entire sides of the chassis for the computer, and then you've got large aluminum blocks with thermal paste and everything else that is bonding the heat pipes onto the aluminum heat sinks that are black anodized on the outside. So there is an extensive cooling capability built into this, and once you put the lid back on, there are basically no easy path because there's no air being forced around. It's, you know, like blowing through the way you would with a fan. You're not going to get dust being sucked into this unit during operation or anything like that. Obviously, if there's a high airflow, you might get some coming in through one of the connectors, although looking at them, they all look like they're pretty tight fitting connectors, so I doubt there'll be much air coming through. And if you wanted something that's going to be sort of IP67 rated, then Perfectron do also have a range that, you know, go all the way up into military specifications that are effectively waterproof and everything else, but they have a whole different range of connectors and things like that, and I'll provide you a link to the Perfectron website at the end of this video. Anyway, a lot of you are thinking, okay, enough of the specs, what can this thing do? Well, with 4 gigs of RAM, obviously you're not going to be running a massive, great big database or anything like that. But from an industrial control perspective, it's quite capable of acting as a control system for factory automation, CNC, you know, maybe driving conveyor systems at an airport, or controlling robots and things like that, or some kind of warehouse automation kind of solution where the environment, you want to be able to just put this in some safe location, but you know, it may not be air conditioned and everything else, and just know that even with forklifts and everything else that are running around, it's not going to give you any problems with the vibration, the humidity, the, you know, the whole environmental thing. And the other place that this can often be used on is, say, in a marine environment where you might want to have it on a boat, maybe as part of a navigation system, or some kind of environmental control or something like that. I mean, who knows? But either way, there are numerous environments where a PC capable of running from -40 to +85 that can take a lot of vibration and not fail during operation, that would be very, very welcome. So I think the last thing to say before we power this thing up is the OS support list. So according to the Perfectron user guide, it supports Windows XP 32-bit, 64-bit, Windows 7 32-bit, and 64-bit, as well as OpenSUSE 12.2 and Ubuntu 12.04. Now this may have been written before some of the later versions come out, and I don't see any reason why, based on the chipset and the CPU, it would not support later versions of all of those. Now, I do happen to know that Windows 10 will quite happily load on this and run. I've already done that, but there's a couple of applications, or at least one specific application I want to run on here, and some of the drivers for some external hardware are not yet updated to work with Windows 10, so I reverted this back to the supported Windows 7 Ultimate Edition, and with that I'm going to load up some CNC software, Mach 3 and maybe a few other ones, and use this to control my CNC router that I have. Now the reason for that is because it's in an unheated environment, and obviously it's going to be a little bit dusty and various other things too because of that. And I'm in the Canadian winter right now, and we're going to be heading down to at least minus 20 degrees C. So I'm going to put this out with the CNC and let it be subject to those really cold temperatures. I will leave it running, maybe put it into wake on land so that I can let it shut down occasionally and then re-wake it up as well, and do some testing on that over the next few weeks and report back to you. But for now, I'm just going to show you the Windows 7 and show you what kind of hardware shows up in the device manager. Really, there isn't a huge amount else to show you on this basic intro review video. You know, it's an i7 quad core running at between 2.5 and 3 gigahertz, depending on what temperature range, and it's the mobile version of the processor, so it has a lot of throttling capability and sleep modes and things like that that it can do. If you have any questions you want to ask or things you want me to try on it, then leave some comments and I'll see what I can do. But for now, that's basically the hardware of the Perfectron PER335A extended range industrial PC. All right, as I said, minus 40 degrees centigrade up to plus 85 degrees centigrade. So if you're in the market for something like that, you should give them a look. The company's based in Taiwan, and I'll provide the links to their corporate website and product websites in the postings.